Welcome to solverfy.
Hello, my name is Margaret, and today I'm going to be helping you with a problem from Chemistry, the Molecular Nature of Matter and Change, 2016. And today we're going to be looking at problem 10 from chapter 8. And it asks, what is penetration? How is it related to shielding? And then use the penetration effect to explain the difference in orbital energies between 3p and 3d, an electron in the same atom. So have here some things drawn out for you already. And essentially what we're going to go through is, define shielding, look at what penetration and effects, what its general effects are, to be able to answer what it's really asking us, which is why are the 3p and 3d orbital energies different? And one of the things I went ahead and drew already are the radial probability functions for the 3d and the 3p orbitals. And the reason for that is because this is where we can physically see mathematically what penetration looks like. So first, let's redefine shielding. And this is basically when an electron that is, let's go back. When an inner or adjacent electron lessens nuclear charge to make outer electron removal easier. Creates overall lower effective nuclear charge. Right? And so basically what we're saying is that, the electrons towards the inside of the atom are creating a barrier to the super concentrated positive charge of the nuclei in the atom, where all the neutrons and the protons are. So they're taking the larger hit, and so it's a lot easier to remove the electrons on the outside. They don't feel as much of that positive pull because of the electrons that are on the inside and between them, and because of some of the electrons that are adjacent to them as well. So what does penetration do for us? Well, so penetration, just looking from the book definition, does two things for us. It increases nuclear charge and decreases shielding. Okay, and how we're going to remember that this is true is we're going to do it with the radial probability functions that we've drawn right here. So what we're saying is essentially that the radial probability distributions, right, are, how it's how likely, sorry, there we go. How likely is an electron to be in this place, right? And we're talking, and we're talking in a radius, right? So from where the center of the atom is moving outwards, right? So how likely it is to be in this particular position moving outwards. And so as, and then this being the probability, the higher this goes, the more likely it is to be in that particular position from the radius. And as it moves further in, the closer it's likely to be to the nuclei, the further away it likely is. So that's how the 1s electrons are more likely to be really close to the nuclei, whereas the higher number orbitals are more likely to be further away, because as we fill the higher number orbitals, they move further away. That's how the periodic table works, right? So what we see is, as we start drawing these orbitals or in these functions, we start seeing that they start getting lumpier. If I were to draw out the all the s's together, we'd see the 1s is right here like this, and then we'd see the 2s is actually so we see the 2s is actually it's a little lower and it goes further out. And then we actually see the 3s is again lower, and then it gets higher the further it goes out, because there is a small possibility that it will be this close. It'll get closer, okay? But because it's the third energy level, it has 3 humps, and this is how this one works. But because of how the quantum numbers work, okay, each size, each shape will have an additional hump as its number goes up. So, the 2p, right, will have 1 hump because it's the 2, right? And so our 3p has 2 humps because it's the next energy level up. So all of that aside, we have this here to show us that drawn out you would normally think that because overall the 3D is overall more likely to be closer to the center, that it would be higher in energy. However, because there is this small portion of the 3p that is inside of the 3D, it ends up overlapping with all of the other important inner orbitals that are already there. So the 1s is in there. The 2s is going to be in here. The 2s and the 2p. And so all it takes is this little bit to be inside in order to decrease that shielding. And so this is what creates those splittings that we end up seeing between the different orbitals. And in fact, it's these little overlaps, these little bumps that jump in front of each other that even creates the orbital shapes in the first place. So why are the 3p and 3d orbital energies different? You know, penetration, which decreases shielding. I wrote that twice, sorry. And that's really all it takes. Because that little bit of extra time that electron will spend further ahead is all it takes for those energy levels.